Hi, it's time for the math easy solution. We're going to discuss some hyperbola examples. I showed in my earlier video how to derive the hyperbola, except the derivation is really long and didn't have time to do any examples. So basically, just to recap here, the hyperbola equations, basically we derived x squared plus a divided by a squared minus y squared over b squared is equal to 1. Or basically, and then if you were to graph this equation, you're going to have something like this. This one is, so it's going to be something like this. This is the x-axis, this is the y-axis, you have something like this. This is y, and this is x. You're going to have vertices right here. This one is a and 0, and this one here is negative a and 0. And these are basically, if you have plus or minus a and 0, these equal to vertices. And then here you had asymptote lines here that this never actually reaches it. So you're gonna have, this is gonna be equal to, y is equal to b over ax, and this one is b over ax is negative. And then you'll basically have here is, so y is equal to plus or minus b over ax is the asymptote lines. Asymptote lines. So those are the asymptotes here. And then this b, we get it from, basically in the derivation we had a fixed point here and here, where this one is equal to negative c0, and this one is equal to c and 0, where they are the foci. So basically plus or minus c and 0 equals to foci. This is basically where we derived it. The equation is basically the hyperbola is the distance, the difference in distance between, let's say this point. It's the difference between this distance and this distance from these two fixed points. You can see my derivation on this. And then from here we get b, which is just, well, c squared is equal to a squared plus b squared. So this is just a recap on before. And then if you were to shift these equations, this one to have y squared over a squared. So if we shifted it to have something like y squared over a squared minus x squared over b squared equals 1, then we're gonna have the equation's gonna look something like, the graph's gonna look something like this, where this one's gonna, it just be shifted upwards just by symmetry. I'm not doing it shifting the letters, the x and y. This is x, this is y, and then once again this point here is gonna be the vertice, except now it's gonna be 0 a, and this one is 0 negative a, and then the asymptote line is gonna be, goes across this again, and this is this goes down to the center here, and asymptote lines again. It's gonna be, but it's gonna be a bit different. It's gonna be y is equal to, this one's negative a over b x. So everything's just opposite of what you would expect from the other one. Y equals b, a again. Yeah, so a over b x. Those are the asymptote lines, and the foci again would be here and here. But anyway, so now let's do some examples here. Let's go with example 1. So example 1, sketch basically this graph right here, which is x squared over 16. Actually, not that equation, this one right here, 9x squared minus 16y squared equals 144. Okay, so here we got to get it to the equation of our hyperbola, so we just divide by like terms, and then this one what we could do is, yeah, we could just divide everything by 144, just so we can get it in the form of the other one, in the form of hyperbola. So from here we get 9 over 144 is, well, we know that 9 times 16 is equal to 144 is actually equal to that. So then we know that this one's gonna be it's gonna be x squared over 16, and then this one's gonna be minus y squared over 9 equals 1. So there's our hyperbola. Then from here we know that a squared is equal to 16, so then a is equal to 4, or plus or minus 4, and then b squared is equal to 9, thus b is equal to plus or minus 3. And then the asymptote lines are going to be y is equal to, well, 3 over 4 plus or minus 3 over 4x. From here we can just graph it. So we're going to have something like this. This is a little quick graph here. So at a is plus or minus 4. So here's 4. This is the vertices. This is negative 4. And then b, we can use this one for graphing the asymptote lines. Y is 3 over 4. So it's just going to be something like this. You can just do a rough one. It's just to get the idea. And yeah, it's going to be something like this. Again, pretty basic. And yeah, these equations, this one is negative 3 over 4x. And this one is plus 3 over 4x. So now let's do another equation, but with slightly different graph we'll get. So as example 2, let's say we wanna, let's say this one we actually want to find the equation, and we're given that the vertices, let's say vertices are equal to 0 plus or minus 1, and the asymptote lines are, so let's say asymptote is equal to y is 2x. Actually, yeah, this is a plus or minus 2x. So from here, and then let's say you want to know the equation. Find equation of the hyperbola. Okay, so from here, vertices are 0 plus or minus 1. So this is going to be in the form of basically y squared over a squared minus x squared over b squared equals to 1. Just because this is 0 and 1. This is the y is the vertice, not the x coordinate. So it's going to be something of this form, and this 1 is, we know that, basically 0 plus or minus 1. This is in the form of 0 plus or minus a, because those are the vertices. So then a is equal to 1. And all we got to do now is find b, and we could just look at b from the asymptote line, which is number y is equal to plus or minus a over bx. So then we have 2 is equal to a over b, and then a over b. So then we'll get, from here we will get a is equal to 1. So we're gonna get 1 over b. Just rearrange this one. We get b is equal to 1 over 2, and then we just plug it in. We have the equation. So we're gonna get y squared, well, divided by 1 squared is a, minus x squared. This is 1 over 2 squared equals 1. Then you could rearrange this one. You get y squared is equal to x, just subtract x squared over, this is going to be 1 over 4 equals 1, or you could even flip this around, rearrange it, and we're going to get y squared minus 4x squared is equal to 1. So there's our equation. So now let's do one final example. Let's say a really hard one. This one we're actually going to shift where the graph would be. So let's say we want to sketch this curve right here. We're going to get a long one here, 9x squared minus 4y squared minus 72x plus 8y plus 176 equals 0. So basically, we want to graph this one. And first thing we gotta do, we gotta rearrange this. So basically, let's put all the x's together and all the y's together, and then all the non-values just across by itself. Since the hyperbola has a 1 on the right side, usually just a positive 1, we're gonna move everything but this 176 to the other side. So we're gonna have, these ones are gonna be basically, we're gonna have 176 is equal to, here we'll just write this down, negative 9x squared plus 4y squared plus 72x. We're just changing all the signs. 8y, yeah, it's minus 8y. And this equals to 176. I just want to write the 176 on there. So now we're gonna let's put all these ones together, all the x values together. 9x squared plus 72x, and this one's gonna be plus 4y squared minus 8y. And we see that the y squared is positive here. Let's say 176. So we'll just put this by itself on the left side. So we're going to have a, let's say 4y squared minus 8y. And then this one's going to be minus 9x squared plus 72x equals 176. And now we could simplify this one, divide this by 4y here. I mean by 4 right here, so we're just going to have 4y squared divided by 2y, because we're going to have to complete the square soon. So 4 divided by out there, minus, this one's going to be, let's say divide the 9 out, negative 9 out, so we're going to have x squared, 72, this is going to be negative 8x is equal to 176. So now we got to complete the square. See my other video on completing the square, but basically, if you recall completing the square, we wanted to write this in a form of, let's say, y minus c squared. And if you expand these ones out, this is just going to be y squared minus 2yc plus c squared. If we look at this one, we have, let's say, y squared minus 2y. And then, so basically c would have to be 1. So we'll just have, so we would have to add 1 here. So basically we would have to add 1 here, and then this is going to be plus 1 squared, and then we also have to minus 1 squared, so we don't affect anything. So what I mean by this one, this over here, we're going to get 4y squared. This is going to be basically y squared minus 2y plus 1 squared minus 1 squared, well, just 1. And then basically on this side, from here, we know that, well, this is basically going to equal to y minus 1 squared. So if we just look at this one, we're going to get 4y minus 1 squared. And then this is actually, we just take it out of there, so we're going to have 4. It's because 4 times is 1 extra, so that's 1 missing one. And then we'll look at this side right here, actually. Now we could complete the square for this side. Again, we're going to have this little thing right here, like that, 2yc, but this time we have an 8x. So divide this by 4, we're going to get, so basically this is equal to 2 times 4x, which is 8, so then c is going to be 4. So we're going to have, in this case, we're just going to write it down right here, 9x squared minus 8x. This has to be a plus 4 squared, which is 16, minus 4 squared, which is negative 16. So we have something like that. And this equals 176. And then so we're going to have negative 9. This is going to be number. This is a 4 squared. So x minus 4. So this is basically completing the square. And then negative 9 times by this negative 16 is equal to 144. This is going to be positive. They're both negatives, so positive. 9 times 16 is 144 equals 176. So now we're going to have basically 4y minus 1 squared minus 9x minus 4 squared equals 176. We're just shifting it all here. 144 minus 4. This is going to be equal to, well, this one's going to be equal to, well, this one, 144, actually, no, this is plus, this is this is going to be plus 148. So negative 144 plus 4 is 140, and then this is going to be, difference is going to be 36, so this is actually just 36. And then from here, we're going to just write this all simplified here. We're going to have 4y minus 1 squared minus 9x minus 4 squared equal to 36. Divide these both by, divide everything by 36 to get rid of it, to make it a 1. So we're gonna get right here, this is gonna be, well, 4, this is just 9, so 1 over 9, and this is gonna be 4, because we know that 9 times 4 is equal to 36. So basically this one, we're gonna get y minus 1 divided by 9 minus x minus 4 squared all over 4 is equal to 1. So there is our equation. Yeah, so this is our equation of the hyperbola. But now you see that it's shifted here. This is -1. This is -4. So it's a bit different. All we're doing is shifting where it is. And if you see my other video on how you can change functions and just by shifting them, all this is, or transformation of functions. All we're doing here, is just shifting this hyperbola. So this is x and y. So now here y minus 1, this just means because if you have y is equal to 1, that's when it's 0. So we're just actually shifting it to the right. I mean, we're shifting it upwards 1. So where basically the center of the hyperbola is. So we're going to have shifted 1 here. And this one here is -4, so this means at x equals 4 is when it's 0, or the origin. So at x is equal to 4 is where we're going to have the center. So this is where the center is. And now we look at this one. This is a squared, or 3. So then we go 3 above to get to this, to get where a is. So we're going to get, say, 3 above, so that's 4. Or this one is equal to a. Because remember, all we're doing is shifting. So this is the vertice. Vertice is at 0, 4. And then similarly we go down -3, so this is going to be 2. -2. Where this is a as well. That's the distance. So we're going to get it right here. And this is going to be 0, -2. That's vertices. Now the asymptote lines. The asymptote lines are just going to be equal to y is equal to a over b, or 3 over, this one's 2, plus or minus of them, 3 over 2, and now this is going to be x minus 4, because we're shifting everything. Everything has been shifted there. So then at x is 4 is 0 again, so then the asymptote is going to be something like this again. Then we're dealing with y minus x squared here, so it's going to be upwards like that. We're just going to draw it like that, and similarly it's going to go through this is the new origin. So this is like, say, new origin. Then we just take this down, and these equations are, again, this is plus 3x minus 4, so y is equal to, and this one here is y is equal to -3 over 2, I'll just divide by 2 here, x minus 4. And then the graph is going to be look something like this. So just something like that, like we've been used to. And this is all, yeah. The graph just looks like what you've been used to, yeah. So that's all, you're just shifting it. You can see my other video on better clarification on shifting and transformation of the functions. Well, that's all for today. Hopefully you learned the hyperbola. Basically, remember, also always remember how to complete the square. If you forget, just remember you want to get in this form, and then just expand it out and just compare how it looks. And then you always have to add in minus. Well, that's all for today. Hopefully you learned, and then how to get hyperbolas, and just rearranging these, like this example here, which is pretty good. It's really long, but pretty good. Well, thanks for watching, and hopefully you learned, and stay tuned for another